Hello and welcome to our second to last webinar. Today we're having a look at the Servo Machine Test System. Sorry, got that around the wrong way. My name's Daniel Brown. I'm here with Product Manager Ralph.
Hello, Daniel.
Ralph, thanks very much for joining us today, and hello to everyone joining in from wherever you are. Interesting fact, we just had a look at the numbers over the last month. This is now our second to last webinar, and we've had over 40 over the last month. We've had over 900 people attend these webinars, so it's been great having you here. Okay, so we're going to have a look at one of the most beloved products here at Lucas-Nuelle. It's been around for a long time, certainly longer than I've been in the company. Ralph, I think almost longer than you've been in the company.
Yeah, almost.
Almost. One of your first products, is that correct?
That's correct. When I started in 1999 here at Lucas-Nuelle, the first pre-model of the Servo Machine Test System was developed, and so one of my first jobs was to relaunch the version 1 of the system.
Okay, so and what we're looking at today is now version number
3.
Number 3. Okay, so it's been through quite a few iterations and constant improvements. So it's one of the products that when I see it, you see it all around in various product ranges from Lucas-Nuelle. We also see it in, I think.
Yeah, in the drive technology, correctly, in the machines, and also in the power engineering area, but also in the refrigeration area, because they have also drives, and so we need also the Servo Machine Test System to emulate systems.
And I think even the automotive are going to start using it as a dynamometer. So probably it's absolutely the most diverse product that we have. So one of the things that I find amazing, which you'll see in the video, is just how you can change the parameters and really simulate or emulate any type of load with this the servo unit. I've seen how flywheels and the system will turn around and react exactly like a compressor, anything. It's really impressive. So I think it's
that's the strength of the system. So to bring the industry or the things into the laboratory and test it and have all the values seeing on the screen, see what happens, find all the values together, and that's the strength.
Yeah, I think it's a great product that you've basically been your baby over the years, so well done, Ralph. Just having a look at this system in particular, the test system. So in this case, we're looking at how electric drives operate and how they function under various loads. So what type of training would this be suitable for? Is this a university or is this a vocational education? Can you just maybe tell us what type of person would?
Yeah, this kind of system can be used in all different levels of training. So starting with electric drives in the technician level, it's necessary to understand the things. If you are later in the university level, you have to calculate things, but you have to test also if the behavior is like you have calculated. So it's used in both. So for technical, low level, and also in the highest level, we use this test system.
Okay. So I think we'll let the video speak for itself. You go into quite a bit of detail about how the system works, what else is found in there, the LabSoft and ILA course, how the system works. So we'll be here after the video to answer any questions that you might have. As always, there's a Q&A section. Just write your questions in there and we'll answer those when we get back. Okay. Thanks. So it's about a 10-12 minute video, so enjoy.
I'm in front here of the Lucas-Nuelle Servo Machine Test System, and I would like to speak about drive technology. Drive technology is one of the most interesting, but also very challenging topic in training young people. At first, I'd like to introduce the Servo Machine Test System. The system consists of the control unit, this is this panel here, and then the brake itself, the black unit here. On the other hand side, we have our machine under test, that orange unit. This orange asynchronous motor is connected to the grid via a star delta switch. At the first step, I like to combine the motor and the brake system. So you need no tools, it's very easy to combine both systems. Then I fix it with the screw, and then we have here a shaft cover which fits exactly between motor and test system. You can see here the green light. This green light indicates that no fault is occurring at the moment. So the system itself is very safe. There are no space between the both machines. The shaft cover avoid touching the shaft. Then each motor has also a built-in temperature contact. So if the motor is too hot or they become too hot, it will trip and the control unit will stop. So everything is done for the safety with the Servo Machine Test System. In the latest version, we have also included, we call it EDD, electronic drive data. So that means every motor transmits his values via a special protocol to our unit here. That means the Servo Machine Test System knows which kind of motor is adjusted and do all the preparings for you. So it makes it much more easier than before to do all the settings. In the next step, I will show you the ILA course, which is coming with the system. The ILA course is in this way, that we start here for the asynchronous motor. On the first page, we see the training contents, the prerequisites, and so you see what is done in the course. Then you get information about the equipment. So at the first step, we have here the complete equipment list. And then for all relevant material, we have detailed description of all the things. Also, the software Active Servo is explained in every course. So for example, if I go to motor characteristics, we will find also small videos which shows you how to operate the system. So here we see how it works. And so you get completely guided in front of doing the experiments. What I like to show you now is to perform 1 or 2 experiments with the system. So I will move to the experiments, taking the characteristic of a star delta switch. So I will move to the experiment page. Here we start again with the training contents for this special experiment. You see here in the next step the circuit diagram. So all the complete wiring, everything is done in a circuit diagram to be on the normal technical level. And in the second step, we have also a detailed picture which shows you step by step doing the assembling. For example, here the PC system, the PE connection, temperature connection, motor circuit, all the wirings are shown in this small animation. In the next step, you will get guided step by step during the experiments. That means here we see start the software Active Servo, select motor characters, and so step by step you get guided. So and I will do this. So in the first step I will open the software Active Servo. So if the software is open, the PC is connected via the USB cable to the control unit. The complete supervising is done by the PC. In the first step, I like to record characteristic of star and delta circuit. So I will start the power supply and I will switch on the motor to the star circuit with the star delta switch. To start the characteristic, I will press enable here. Then I have to switch the enable, the one button here on the control unit. This is a safety feature, so the software asks to push the button here, so the students or the student know that now something happens to our machine. Say OK. Then I press the output ramp button, and now the motor gets braked step by step from the no load speed to the standstill speed. And what we see here in the characteristic in the graph, that is the characteristic for the Y circuit, for the star circuit. The next step is, I will press the enable button again, and now we switch the motor to delta connection, and then we will see how the motor behaves in delta connection. I will press the enable button again, start the system pressing the one button, going to output ramp, and then the system records the characteristic for the delta. So I will switch off the motor, software also, and what we see here is we have a big difference between the both torque. And so we see, okay, if the motor runs in Y connection, star connection, the torque would not be as high as in the delta connection. What should we do with such characteristic? For example, I like to see also what is other values given from the motor. So I make a double click here. For example, I select current, and I see, okay, that's the motor current. Then I can take this picture, say copy, and paste it to a special placeholder in our ILA course. These ILA courses are able to print out later if you have done the laboratory, and so you get all the information to take it back to home. Now we have seen one side of the medal. We have looked on the motor side, but motors in the industry are not only motors, they are applied to drive a working machine. And now we come to the working machine. For example, we have in the industry a big ventilator, and the idea is now to bring this ventilator in the laboratory. So what we did in the software or in the system, we implement the characteristic of the ventilator in our Servo Machine Test System. So the black unit behaves now like this ventilator. So I move here, I move here to the point load simulation, and then I can arrange different load or working machines. For example, pump, ventilator, car lander, hoist drive, compressors, winding machines, inertia wheel, or time-dependent load. So we have all the well-known loads in the software, and they can used in the laboratory. Now I have adjusted the ventilator. The size of the ventilator can be changed by the value load constant. So I put a special value inside. Normally these values are given in the ILA course, so that the student has to know which is the correct value. And if I press the enable and start the system, the black unit here, our Servo Machine Test System, will behave like the ventilator. If I start now the motor, we see the working point comes across both characteristics between ventilator and the torque line of the motor. If I move to delta, I see the behavior. Normally, this behavior is shown on the whiteboard, drawing all the lines, and you see you have to believe that the working point is exactly at that point. But with the hardware here we have now, you can do it in an experimental way, which helps the student to understand the interaction between the both systems. Now the question is why we use star-delta connection. star-delta connection is used to reduce the inrush current of motors. Let's try to do one other example. I will move to another working machine like a hose drive, which could be a normal tooling machine in the industry. And if I look on the motor weight blade, I see, okay, this motor has a value for approx 0.37 kilowatt. And so the torque should be around 2 and something Newton meters. So I applied here a value of 2.2 Newton meter for the torque. And now I try to run the motor with the star-delta switch. I enable the load, press OK here, start to Y circuit or star circuit, and nothing happens. The motor couldn't start. There's no torque, not enough torque to start. We see here the working point is at this point, and no turning of the motor. If I go to delta, I see, okay, the motor is turning. So for example, for this special machine, star delta is not working. But what is happening with the current inside the system? To discover the inrush current, I will choose another load machine, working machine. I choose the inertia wheel, and then I change the flywheel to 1000 kilogram square centimeters. And now I can also adjust the axis for this. I will choose 20 seconds. For the trigger, I can choose the speed, for example. And here with this small anchors, I can select the triggering point. So now I have adjusted the flywheel with the values. But for the inrush current, it's also interesting to see the current. With a double click, I can adjust the current here. Start enable again. And press record button. What we see here is now all the values are measured. And now I can start in the next step the motor. If I start the motor in the Y, see what happens, and then I switch to delta. And I can see directly the behavior. So we start here with a small current, then with a higher current if I switch to the delta. And we see also the torque which is given by the speed up of the system. If I stop it again, press stop. The challenge now is to reduce this inrush current up to, I will say, 1.5 amperes. So the students has to find the right time, the correct value to do the switching, to understand what happens. So this knowledge can be used, transfer later for the industry to understand what happens then. So what will we do? We will do the same experiment again, press 1 again, press record again. And now I start in Y circuit. And now I have to wait until the right point is given to switch to delta connection. And now we see we have reduced this high inrush current to a small value. I will stop it here. This demonstrates you how easy it is to bring these things to the laboratory to understand what happens. So we have real life situations in the laboratory, and we have the tools to show it, to visualize all these things and make it clear. That's for the students and the workers for tomorrow. They understand the behavior between motors, drives, and working machines, and can transfer this knowledge to the industry later. The experiment I showed you was only a first impression of the system. So we start with an asynchronous motor, but the system can only also handle DC motors, synchronous motors, AC motors. Every kind of motor can be used with the system. Or you can expand the system to a real power electronic system like frequency converter, industrial or didactical ones. So you can use it in many ways. If you have further questions, please visit our website or contact us.
Okay, welcome back. So great video, Ralph. Thanks very
Thank
much.
you.
I think that gives a really good explanation of the system and one instance how it can be used in this field for electricians and people understanding electrical drives there. So we're just talking about the active servo. We just seen that on the video there. You were saying that a lot of universities have their own core structure, and they don't need the theory that's often brought about by the LabSoft or the interactive lab assistant courses that we have. They do it something a bit different, so that's why active servo is its own program. Is that correct?
That's correct, because sometimes people will not operate in our EILA core system because they have special or their own ideas, and so for example they use Word or some other tools to do their preparation for the laboratory, and so we can use this active servo software, and with copy and paste we can also copy then our data to this Word file, or we can use export function to put data to MATLAB or to Excel. So it's quite open, the system.
Very versatile. So if you're not aware with LabSoft, the way you see, if you have an oscilloscope or any type of picture, you can copy the picture and then insert that into your user file. So the user that logs into the LabSoft, and what you're saying is you can then do that in any document as well. So Word file, it captures all of that data as well. So it's another great feature there. Getting a few questions coming in here. So does the new dynamic servo machine test stand also work without software in manual mode?
Yes, we have implemented a manual mode, which is available for torque and speed control, and we can also do synchronization of the synchronous generators with this unit in manual mode. Okay.
Fantastic.
And what I have to say also you can have all the measurement data on the big screen now. So either mechanical and also the electrical value can now be shown on the screen.
Okay. The word mechanical and servo here just reminds me of a story that one of our colleagues was talking about when he was doing his studies in this field. He said that the servo brake that they used was a piece of wood against the electric motor to load it up. So I find it quite amazing how technology has progressed to the point now that you can really visualize all of this data. It makes it so much easier to understand. We're talking about, for me especially in the company, my focus has been automotive, mostly within the company here and with electric vehicles. And Ralph, you've spent some time with me to help understand how electric motors work in electric vehicles. It's the same across all.
It doesn't matter if it's a vehicle or it's industry.
And I must say, up until, from what I've tried to understand in the past, has been about in textbooks, things like that, and it is really hard to understand. And I think using the equipment here makes it so much easier. But also I think some of the landmark animations that you've produced is how the three-phase electric motor works, how you can see the rotating magnetic field, which is something which takes pages to explain in a book. But here you can explain it in a number of animations. It makes it so much easier to understand when you can visualize and then also get to work with the equipment as well. Okay, so a couple more questions coming through. Does the software active servo come as a separate line item, or is it included in the hardware?
So the software is directly included in the hardware. So we like to have a complete package. So we include hard and software together as one package.
Okay, that's certainly a bonus. Can one use the system on a generation operation? So I guess is that can you talk about using the servo to run generators, for example?
I think that's a question. Yes, you can use it for one generators, either in island mode, which is not grid tied, or you can also use it in the way that you have a grid tied generator. You synchronize it, and then you deliver power to the grid. So, like in a power engineering area, we do it in this way.
If you ever get the chance to come to our showrooms here and have a walk around, you'll see this unit is literally everywhere. It's and just looking at these systems here, so we use it to simulate wind power turbines, for example. So it can absolutely simulate all of those different conditions. I think you might have just answered this one, but can grid synchronization experiments with synchronous generators also be conducted?
Yes, as I told, it's very easy to do this synchronizing experiments because we have the special mode for synchronizing, and so it's very easy.
Okay. What happens when the MUT gets hot? What would the MUT be in this?
MUT is machine under test, I think.
Okay.
So all of our machines consist of a temperature contact, and this temperature contact is connected to the Servo Machine Test System, and the temperature contact releases or give a signal to the servo system, and if the motor is too hot, the motor will, or the servo system will stop braking.
I think that's an important safety factor there, because the whole system will then shut down then, and to keep to protect the engine.
To protect the engine and cool down, and then after the machine is cooled down, it starts again. And also we put a certain level between the maximum temperature and the trip temperature. So the trip temperature is lower than the maximum temperature of the motor. So we have a little bit space to have a safety margin. Safety margin that it's almost impossible to burn the motor.
Okay, yeah, that's certainly good at schools there. Yeah. One of the things that we seen in the video as well was the new symbol EDD.
Yeah.
So I think that's a fantastic initiative, because it saves so much time for the students.
Yes, the EDD stands for electronic drive data. So every motor we provides this data in a special protocol which can be read by the Servo Machine Test System. And this is done over the shaft cover. So there's no additional wire is used, there's no RFID or something. It's done even if you put a shaft cover on it, and then it can be read out. And the benefit of it is that many presets are done for the students. So they can concentrate on the operation of the system. They don't need to fill in data, so everything is pre-configured.
I think, especially when you've got so much to learn nowadays, the time you have in the laboratory is really important.
So they can concentrate on
doing that.
Yeah, on doing
experimenting and finding out how the systems work, as opposed to simply typing in the information. Okay, the questions are coming in thick and fast now. So question from Paul: with the rise in electric drives in vehicles, is there application relevant for automotive technicians? Is this application relevant for automotive technicians? Maybe I can answer, or we can discuss together, but looks like a camera just cut out there, but I would say in this case, it's certainly good to understand it. But in automotive, I would say there's not really an automotive technician. This is now in the research for engineers who have to understand how the electric motors understand. That would be more relevant in the automotive field, at least.
I think you have to look on the level the student is, or the trainee is. So if you are on the level of the university, you study automotive technology, certainly is absolutely a point what should be trained.
Yeah, it's It's certainly interesting. There's not much in the way of where the curriculum says you have to go into so much detail, but it's. I think there's certainly be plenty of technicians that would love to play with the systems to understand it. I think there is another one of your products that you've developed is the Unitrain model is also very good for understanding the introduction into drive systems for electric hybrid vehicles. Another question, can a customized torque load be programmed?
Yes, we are just working on this area. So what will we do? We will implement a special programming load so the customer can program her own load. For customer who knows our SCADA for Power Lab, we have built in a PLC technology. And this PLC technology is now built in our Servo Machine Test System. So we will provide, I think in January, an update of our active servo software.
Okay.
And in this new update, also the sold systems can be updated to run this programmable loads.
Okay.
So we put in now the software to do that, and I'm just working on this project to implement this programming.
Okay.
And that's very funny. So you can program your own loads, the own designs of the loads.
Okay.
Today I program a sine wave, and so the motors swim out and swing out.
Really?
So like in a sine system, and so we can do all the things what you can imagine. That's very nice.
That's really cool. Yeah. And that software will then be backwards compatible.
It's only for the third
generation.
For the third generation, but also for the systems which are sold.
Okay.
There's only some additional software which comes then with the active servo.
Okay. Looking forward to seeing that.
Yeah.
There's a question that comes related to that is, what is the maximum torque the unit can provide?
So we have two different units. One unit is for the 300 watt section, and this unit can provide up to 11 Newton meters. It's more than enough to break the motors down. And we have some reserve, yes.
Okay, yeah.
To have to the maximum load of the motor, the maximum torque of the motor. And the other power range is the 1 kilowatt power range, and this system deliver up to 30 Newton meters.
Okay.
Also more than enough to break the motors.
Okay, how do you actually measure the torque? Do you still use a strain gauge torque transducer?
No, in this case we use a modern industrial servo unit, and in the servo unit the torque will be calculated by a special motor model which is given from the servo motor and the electrical values, and so you can calculate the torque very, very good from this model. And so we use this value and then we get the torque. Okay. We do a calibration here internally, that we will have a look on each system. Is the torque correct, what comes from the industrial version? It's not, so we will calibrate these values completely. So we do the measurement of the torque.
Does the system need to be calibrated again?
No. Also, the system measured the temperature of the servo machine, and also it adapted the model to this temperature change. Okay. So it's very accurate, the power which can be measured by the system.
Wow, okay. So
there's no need to recalibrate things. There's no things what can be damaged. So for our purpose here, I think it's the best solution.
Perfect. Okay. Still coming through with some questions. Can the unit communicate with MATLAB or LabVIEW?
So LabVIEW communication was done with the version before, and also with this version it could be possible, but we are also thinking about communication with MATLAB, but that's on the way, on the development chain. So first we would like to have this PLC technology built in, and also the combination to the power engineering area, where we use it in combination with the SCADA software. And if this finished, then we are looking forward to do the integration for MATLAB.
I think that's the digitalization. When you say everything is calculated internal, there's no mechanical parts which are measuring things, that really makes it possible to have the communication with these external softwares.
Yeah.
Okay. Paul's just got a question here, which maybe I can answer. Is there a plan for integration with LN's car train in the future, or the topics for drives and PE are only general? So I think you've developed quite a few automotive crossovers from your area. I think there was the battery was one as well. Did you have there was some sort of battery system?
No, I don't think with the battery system. It was
there was a drive for research purposes.
Yeah, it was twice for research purpose, but we have also developed a system which can be used in the automotive area. So we emulate a car which runs a hilly area or special way to have all these things which are done. The problem is we have to find customer for these solutions, and that's, I think, it shows a little bit difficult. So we have a solution for that. It's car train, another e-car train. I don't know if you know it. So it was an emulation with power electronics and the Servo Machine Test System to have a deeper understanding of how the drive will work. But you have to find the customers for this topic. It's not the technicians.
Yeah.
It's
people designing the components inside the vehicle, the inverters and the complete drivetrains.
So that's a product for universities.
Yeah, I have seen the Ishwar gave me a demonstration where you could see the vehicle driving up and down hills, and then the system reacts. So that, again, the survey brake is then able to load the motors up, and you can then test different characteristics of the frequency converter, which is driving the motor, is my understanding.
Yeah, you can also build different CV factors, different wheel radius, and so
coefficients of friction.
All this can be done, and then you see how much energy is used and what is doing the things, what is about the weight of the car, and all these things can be looked up.
If there's any, I think this product was probably ahead of its time. It was too early because we're really starting to see that transition to EVs now. So I think it might be something where we can have a look at again. Obviously, we've got here in Europe, we just heard from one of our customers that Iceland, for example, are now sold more than 50% of all new cars sold are electric vehicles. Yeah. So I think that might be time for that to...
Perhaps it's now time for having a new look about the training system.
Absolutely. Okay, so that looks like it's it for the questions. Ralph, thanks very much for coming by today and explaining and showing us the system. It's a great system.
Thank you.
And thanks to everyone who's joined in today. It's great to see you here again. And tomorrow morning, although for those of you in the USA who are watching in tonight, probably will miss that tomorrow. But well, hang on, we've just got one last question. So before we go away, what happens if a student removes the shaft guard? What's going to happen to the system?
So the system will stop immediately. So we will switch off all the power of the device under test, and we will also switch off the Servo Machine Test System, so it's safe.
Okay, makes sense.
Yeah.
Okay, all right. Again, thanks very much for joining. It's great having you here, and we will continue webinars in the future. So this is not the end of our webinar system, but we won't be doing as many as we have done here. But as new products come out, maybe when you have the new Active Servo software, we will have a look at doing more live webinars, live demos, actually showing the equipment being used. And so we look forward to seeing you in the future. Okay, thanks and bye.
Bye-bye.